let me delve just a little deeper into what happens when you export metadata pre-12.2 or 12.201 and later, because that's the dividing line where we implemented parallel metadata export and import for data pump. What will happen is for your 12.201 and later databases, 18, 19, and so on, most metadata will be exported and imported in parallel. And I say most there because there are some types of metadata that have dependencies, such as types, where you might have a type hierarchy that needs to be exported or imported in a particular order due to type evolution. But for most metadata, we will export and import it in parallel now. So what did we do before 12.2? Well, before 12.2, when we were exporting, the very first phase that you're going to see in your log file is the estimate phase. And what we will do by default is we will look at where the data is laid out in your data files, and we'll count the blocks. So we'll go query the DBA segments, views, and so on to find out what are the biggest objects that we need to export. And that way we can get the right ordering to make the export as efficient as possible. But that estimate phase can be time consuming on a large database. You could speed it up by saying estimate equals statistics, but sometimes you don't have accurate statistics, and then that can throw off the export process itself. And only once we're done the estimate phase will we then start exporting the metadata with a single thread, and then we will also export the data using parallel processes. Well, we mix that up in 12.2 to make it more efficient. With parallel metadata export, we start exporting the metadata as soon as we know what it is that we need to export from the database. So we gather the set of objects we're going to work on, and while we are estimating the data sizes, we start exporting metadata in parallel. And again, it's most of the metadata will be exported in parallel. We're talking about things like users and table definitions and constraints and roles and so on. So if you look at your log file, you can actually see this difference in how we operate right there in your log file, especially if you use the metrics equals y parameter that I advised you to use earlier under best practice. Pre-12.2, what you can see is that we start with the estimate phase, and then only once that is completed do you see the startup of our other parallel worker processes. So that means we've only got one thing happening until the estimate is done, and then we start all those parallel processes to start actually doing the real work. Whereas in 12.2 and newer databases, what you'll see is we start up all those parallel processes right away, and then as soon as they can, they get going on exporting metadata, and eventually, after the estimate phase using statistics, we will start exporting data as well. So it makes the whole process much more efficient, especially for those metadata heavy databases like your SAP databases, your e-business suite databases, and other enterprise applications. So I mentioned this earlier in terms of best practice, but it's a really good idea to have up-to-date statistics on your sys and system schema, because both the estimate phase and all of this export of metadata is going to be a heavy user of dictionary tables and fixed objects. That will make your estimate phase and your metadata export go so much faster if you have good statistics there. So now let me just give you kind of a boxes and arrows type of example of how this really plays out in terms of processes. Let's say you've got 3 subpartitions that you're going to export here, and you specify parallel equals 6 for data pump. In this particular table, as I said, 3 subpartitions. And we're using a wildcard so that you get parallel dump files, which is the right thing to do. Now, how many processes would you expect to get out of this example when you said parallel 6? Answer might surprise you, because what you'll get, first of all, is the control process. So that's 1. And then you have 1 process that is unloading the metadata in this case. And then the next worker might look at a partition and say, that is above the threshold of size where we would use intra-partition parallelism of external tables. So instead of just unloading that data myself, I will call parallel query and invoke 2 PX processes to unload that partition in parallel. And then the next subpartition might be smaller. Maybe it's below that threshold. So we have maybe 1 direct path unload of that subpartition. And then the third subpartition, again, is larger and takes advantage of 2 parallel processes. So that gives you the 6 active processes that your parallel 6 that you specified for data pump asked for. You've got 4 PX processes and 2 worker processes, one on metadata and one doing direct path unload. The other workers are coordinating things. But what you also have are 2 currently idle processes, worker processes that aren't doing anything because you specified parallel 6, and we only want 6 processes unloading data at any given time. So even though you said parallel 6, we end up with a total of 11 processes here. We have the control process, we have 6 worker processes, and then we have the 4 parallel query processes running all at the same time. Now, some of those processes are idle, but it pays to remember that this can happen because the process count on your system may throttle the number of processes that you can spawn.